Hey everyone, so I'm here again this time to tell you a little bit more on alpha, beta and gamma radiation. So we already know what they are and we even know how they decay. So I can have isotopes, which are atoms of the same element but with a different number of neutrons, and they can have a nucleus that is unstable, and they become more stable by emitting radiation. Now, the radioactive decay could be an alpha or a beta decay, and then accordingly is going to change how the equation shows. So I'll tell you that in a second because I don't think next slide has this part. And then a gamma emission comes along with any of them when there is an excess of energy. Now, you also need to know well the atomic number, which is the number of protons in a nucleus that is given by the symbol Z, and the mass number, which is the number of protons and neutrons in a nucleus, which is given by the letter A, okay, on the top. So this is just the recap of the radioactive decay. So if you don't know what I'm talking about, please go on the previous video on the decays for alpha, beta and gamma, because this video builds on it. So it's more information about alpha, beta and gamma, okay? So remember when I told you like the properties of alpha, beta and gamma? So what I have in here is in a table everything summarized for these three type of radioactive particles in terms of the symbol, penetrating power, what stops them, and their ionizing effects. So alpha is the least penetrating of all the radiation. Alpha is easily absorbed by paper or a few centimeters of air, about 5 centimeters is enough, and is the most ionizing. Beta is always in between alpha and gamma in terms of penetrating power and ionizing effects, okay? And is stopped by a thin sheet of aluminium or 1 meter in air, okay? Gamma happens to be the most penetrating, is only stopped by thick lead or concrete, and it has an unlimited range in air. Actually, range should be saying in here, okay? And is the least ionizing. So, as you can see, it goes from alpha, beta and gamma. Beta always in the middle. The most penetrating one happens to be the least ionizing, and the least penetrating one happens to be the most ionizing, okay? So this table is something that you need to know by heart, okay? So you need to understand this well. You also need to know well what stops alpha, beta, or gamma, okay? So, why is this important? Well, if you remember the electromagnetic spectrum, then you have different parts of the electromagnetic spectrum. I'm going to start with a high frequency and therefore high energy and short wavelengths down to the long wavelengths, which means low frequency and energy. So the bigger the wavelength, the lower the energy, the lower the frequency. So the electromagnetic spectrum goes in order from the higher energy to the lowest energy as gamma rays, X-rays, ultraviolet, visible light, infrared, microwaves, and radio waves. Now, everything above the visible light, so gamma, X-rays, and ultraviolet, they are known as ionizing radiation. So this is because they have lots of energy into each photon and they can ionize. So these photons can have a strong local effect. They can kick off an electron of an atom and make it into an ion. The ones including visible light and below, they are called non-ionizing radiation because they don't have that much of a local effect. They cannot really kick off an electron out of an atom. So they carry less energy in each photon, and their main effect is warming. Now, alpha, beta, and gamma, these gamma rays is that gamma radiation I have been telling you, and you know that is, let me show you the table again, the least ionizing. So that means that alpha and beta are just above in the terms of how much they can ionize. So that means that the ionizing effect of alpha is enormous, then it goes beta, and then it goes gamma, which you guys know is used for sterilizing equipment, killing bacteria, and also kill cancer cells. So it's used in cancer treatments, okay? So what is this thing of ionizing radiation? Because I know that alpha, beta, and gamma are all ionizing. So ionizing radiation. Photons, or packets of energy if you want to think, from ionizing radiation, they have enough energy to kick an electron out of the atom and produce an ion, okay? So this is the high energy radiation. It hits the ion, the electron. The electron gets out of the atom. Therefore, I have an atom that doesn't have the same number of protons and same number of electrons, and therefore it has an overall charge. So it's an ion, okay? So, what is the problem? Ionizing radiation can alter the materials it strikes in. In case of living cells, it can damage, destroy them, or kill them, starting a cancer. So, what happens is you get radiation hitting a cell, it will destroy the DNA, or it can destroy the DNA of that cell. You get one bad cell. Now, how do cells grow? They grow and they clone themselves. So one cell becomes a complete new equal cell, a clone. So if I have a bad cell, that bad cell is going to grow into another bad cell, that grows into another bad cell, and so on. So I have lots of bad cells. And when I have these bad cells, also the growth can be uncontrollable. So it can be, or maybe it's better to say out of control, in the sense that I can control it with certain medicine uses, like for example radiation, but it's out of control, so it's faster normally than the normal growth of other cells, healthy cells. So if I get one bad cell, one cancer cell, and it grows by cloning itself, I will get lots of bad cells. So that's going to be called a tumor. So ionizing radiation can start a cancer, okay? So, more stuff that we need to know in terms of safety and ionizing radiation, so alpha, beta, and gamma especially, okay? I can be irradiated or I can be contaminated by radiation. Irradiation is when an object is exposed to ionizing radiation. So, I'm in the same room as, for example, alpha. I am being exposed to it, so I'm being irradiated. Contamination is when I have the unwanted presence of materials containing radioactive atoms on other materials. So if the radiation, for example, imagine that I get something from Marie Curie's lab and I put it in my bag. So I have a material containing radioactive atoms in another place. So my bag will be contaminated because it's full of now radiation that was brought in by another material, okay? You need to know the difference between irradiation and contamination. Irradiation, I'm around it or is around me. Contamination, I have it present on me, okay? Now, other stuff that we need to know. We know about alpha, beta, and gamma, and we know what can stop them, and we know how much they can travel in air. So that means that alpha is the most ionizing, right? But it's also the one that has the shortest range. So alpha is the most dangerous inside the body and is the least dangerous outside the body. So alpha irradiation is not as bad as alpha contamination, okay? So if I have it near me, it could be that in about 5 centimeters it's going to be absorbed, or it can be that it doesn't even get into my body. But if I happen to breathe it in, for example, in the mines there is a lot of alpha radiation. Imagine that I'm not wearing a mask. If I'm breathing it in, then it's going to go inside my body, into my lungs, which are quite sensitive. So that is going to be very dangerous, okay? Gamma radiation is the least dangerous inside the body, and this is because it's the least ionizing, but it's the most dangerous to have outside the body because the range is unlimited, so it can get inside my body. It can pass through my skin and get into my cells. Is that making sense? So although alpha is the most ionizing, because it has the shortest range, is the least dangerous to have inside my body, however, is the most dangerous to have I said inside, I wanted to mean outside, so I'm going to repeat it again. Alpha radiation is the most ionizing, but it's also the one that has the shortest range in air. So it's the least dangerous to have outside my body and the most dangerous to have inside my body. On the other hand, gamma radiation is the least ionizing, but the most penetrating. Therefore, it's the least dangerous to have inside the body, but the most dangerous to have outside the body, okay? And this has all to do with irradiation and contamination. Finally, the last thing you need to know for this particular lesson, there is going to be more on alpha, beta, and gamma, but the uses in terms of medicine or in the industry. But how can I separate them? Imagine that I have a beam that has all types of radiation, and I want to separate alpha, beta, and gamma. I can use their properties either by using a magnetic or an electric field. Think about it. Alpha has a positive charge, beta has a negative charge, and gamma has no charge, so is uncharged. So I can get a plate with a positive end in one side, with a negative end on the other side, and then gamma will not be affected because it doesn't have a charge, so it will pass through. Beta, that is negative, is going to be attracted towards the positive end of my plate, and alpha, which has a positive charge, will be attracted towards the negative charge of my side of the plate. So I can get that by using either a magnetic field or an electric field. Now, alpha also is more massive than beta. Beta is just a fast-moving electron. Alpha is made of 2 protons and 2 neutrons, so it's more massive. So beta will turn towards the positive plate very quickly because it has a short mass, but alpha, that has a bigger mass, is going to get deflected, but not as fast as beta, okay? Because you would need to make more effort for a bigger mass to turn, okay, to change the trajectory. So how does it work? Alpha has a positive charge, is harder to deflect, but it goes in the opposite direction to beta. Beta has a negative charge because it's a fast-moving electron, so is easily deflected in the opposite direction to alpha, and is easily deflected because it has a smaller mass. Gamma is electromagnetic radiation, is uncharged, so it does not get deflected. The same if I use an electric field instead of magnetic field. Alpha is attracted towards the negative plate because they are positively charged. They are deflected less due to their higher mass. Beta is attracted towards the positive charge because they are negatively charged, and gamma has no charge, so does not get deflected. So this is how you can use your knowledge of alpha, beta, and gamma to separate them in case you have a beam with all the 3 of them together. And that is it. So today we got a summary of penetration power, stop by, and ionizing effect of alpha, beta, and gamma. We saw why alpha, beta, and gamma are dangerous due to being ionizing. We saw the effects of being ionizing. We saw the difference between irradiation and contamination. We therefore saw which irradiation would be the best or the worst to have inside or outside my body. And finally, we use our knowledge of alpha, beta, and gamma to know how we can separate them in case I have them all together and I want to separate the different radiation. So that is it for today, and up to my next video. Be happy and healthy. Bye!